Hey everybody, it's Mr. Shoemate. This week we are going to be working on approximating square roots and cube roots. So what we're going to do is we are going to start off estimating square roots and cube roots to the nearest integer. Our first problem says we need to estimate the square root of 83 to the nearest integer. So if you'll notice, the square root of 83 is not a perfect square. We know what the perfect squares are though, correct? We know that the square root of 81 is 9, and we know the square root of 100 is 10. So that means the square root of 83 must be somewhere between 9 and 10. Hopefully that makes sense to you. Let's go through this problem and check it out. Okay, so if we're going to estimate the square root of 83 to the nearest integer, we know, again, the largest perfect square less than 83 is 81, because the square root of 81 is 9. And the smallest perfect square greater than 83 is 10, because the square root of 100 is 10. So again, our answer has to be somewhere between 9 and 10. So we can plot each square root on a number line and then estimate what the square root of 83 is. So here's a number line that goes from 9 to 10. And if you notice, the square root of 83, it's right here closer to 9 than 10, because the square root of 81 is 9. We know the square root of 83 is closer to the square root of 81 than it is to the square root of 100. So estimating on a number line, the square root of 83 would be about right there. So next, since 83 is greater than 81 but less than 100, that means that 83 is greater than 9 squared but less than 10 squared, which means the square root of 83 is greater than 9 squared but less than 10 squared. So again, just saying that the square root of 83 is between 9 and 10. We know it's closer to 9. So since it's closer to 9, the best integer estimate for the square root of 83 is 9. Now we're going to do it the same way for cube roots. In this problem, we need to estimate the cubed root of 320 to the nearest integer. So the cube root of 320 to the nearest integer. Well, the smallest perfect cube less than 320 is 216. And the smallest perfect cube greater than 320 is 343. We can see here that the cube root of 216 is 6, and the cube root of 334 is 7. So we know that the cube root of 320 is somewhere between 6 and 7. So we just need to do a little work to figure out exactly where between 6 and 7. Is it closer to 6 or is it closer to 7? So what we want to do, just like we did before with the square root problem, is we can use a number line. So on a number line, the cube root of 320 is right here between 6.75 and 7. So it's very much closer to 7 than it is to 6. So the best integer estimate for the cube root of 320 is 7. Okay, if we look at this next problem, it says Wyatt wants to fence in a square portion of the yard to make a play area for his new puppy. Now, you know, when you're fencing in a square portion of your yard, you need to know how much fence you're going to buy. It says this area covers 2 square meters. But if you notice, the side lengths of this square are square root of 2 meters. So in order to find the perimeter of this square, which is what we need to figure out how much fencing he's going to have to buy, we're going to have to take the square root of 2 and multiply it by 4. That'll tell us how much fencing he needs. But what is 4 times the square root of 2? That's not something you can easily do in your head because the square root of 2 is an irrational number. It's a non-perfect square. So he's going to need 4 times the square root of 2 meters of fencing. The square root of 2 is between 1 and 2. So 4 times the square root of 2 is between 4 and 8. Is this the best approximation? So we can truncate the decimal expansion of the square root of 2 to find a better approximation. And we'll talk about what truncating means. So we estimate the square root of 2 by truncating or dropping the digits after the first decimal place. That's what it means to truncate. If you're truncating the decimal expansion of the square root of 2, it means you're dropping some of the digits. You're not using all of the digits. Now you can use a calculator to find out what the square root of 2 is, but then you need to truncate. You need to drop some of those decimals. So the square root of 2, since it's an irrational number, that means it's non-terminating and non-repeating. It goes on forever. So we truncate or drop some of the decimals. The square root of 2 is about 1.4. We're truncating or dropping the digits after the first decimal place. So 4 times the square root of 2 is greater than 5.6, which is 4 times 1.4, and it's less than 6, which is 5 times 1.4. To find a closer approximation, you can expand the square root of 2, then truncate the decimal expansion after the first 2 decimal places, or even after the first 3 decimal places. The more decimal places you have to work with, the more accurate your answer is. So the square root of 2, if we want to add another decimal place, is about 1.41. And that means 4 times the square root of 2 is greater than 5.64, which is 4 times 1.41, or it's less than 5.68, which is 5 times 1.41. So our answer is between 5.64 and 5.68. So if we want to know how much fencing Wyatt needs to buy, he needs to buy about 6 yards of fencing. So now what you're going to do is you're going to go to the assignments page in Canvas. I have some assignments laid out for you there. You're going to click on some of the videos and some of the tutorials to walk you through how to approximate square roots of non-perfect squares or square cubes or cubes of non-perfect cubes. So you're going to do the assignments by clicking on the videos or the tutorials and watching those. And then what you're going to need to do is log into Khan Academy and using your username and password, log into Khan Academy. And I have a practice assignment in Khan Academy for you to do. You have this week to do it, and it is a graded assignment. So take your time this week and work on that practice assignment in Khan Academy. You should be able to do it as many times as you need to get the best score that you can. And if you have any questions or need any help on this week's assignment, on Tuesday, I'll be in Zoom, and you'll be able to come in there and ask any questions that you have. I'll leave the Zoom meeting code in the announcement section of Canvas, and I'll also send it out on Remind. So that's about it for now. Hope to see you then.